We now briefly discuss the measurement of current and voltage. Voltage is measured with an instrument called a voltmeter, and current is measured with an ammeter. A measurement device called a multimeter has several functions and can usually measure voltage, current, and resistance, among other things. The measurement of voltage and current follows conceptually from the meanings of these quantities. The voltage between 2 points is the potential difference between them, and the current is the amount of charge per unit time that passes through an imaginary area, which can be taken to be the cross-sectional area of a wire, for example. Therefore, voltage is measured between 2 points or across a circuit element of some sort, a resistor, for example. Current is measured through a point or circuit element. For example, if we wanted to measure the voltage across the resistor in this circuit, we would hook up the inputs of the voltmeter with one probe at A and the other at B. This measures the voltage between points A and B, which is also the voltage drop across the resistor. When making such a measurement, it is important that the probe with which you are measuring does not affect the circuit while in the measurement process. This is why the effective internal resistance of the voltmeter, Ri, is important. Since the voltmeter's effective internal resistance is in parallel with the resistance between A and B, the internal resistance should be much larger than the resistance between A and B. This is so that only a negligible amount of current from the circuit goes through the voltmeter rather than through the circuit's resistor. An ideal voltmeter would have an infinite internal resistance. When using an ammeter to measure current, the ammeter is placed in the circuit so that all of the current running through the circuit also runs through the ammeter. The way the ammeter is placed within this single loop circuit, all of the current running through the loop must go through the battery, the resistor, and the ammeter. Now, just like the voltmeter, the ammeter also has an effective internal resistance, Ri. In this case, the effective internal resistance should be small, so that there is a negligible voltage drop across the internal resistance, and it doesn't change how the voltage is distributed in the circuit. Therefore, an ideal ammeter would have zero internal resistance. In reality, voltmeters do not have infinite internal resistance, and ammeters do not have zero internal resistance, and sometimes the non-ideal nature of these devices must be taken into account.